Hi everyone, welcome to the All Things XR podcast. I'm Mujtaba. In today's episode, we have a conversation with AJ Keller, co-founder and CEO of Neurosity. Neurosity is a company that's working on BCIs, brain-computer interfaces. Hi AJ, welcome to All Things XR podcast.
Hey, how you doing?
Thanks. So AJ, can you tell us more about yourself and your company Neurosity?
Yeah, for sure. So my name's AJ Keller. I'm the CEO and co-founder of Neurosity. I'm the lead hardware engineer with a background in computer engineering. I have about 6 or 7 patents to my name. A lot of focused on, headwear for computer control and really like the main technology that we've been creating here at Neurosity. And what Neurosity is really a vehicle, a company that we want to become the most trusted and loved neurotechnology company in the world. And we want to create products that really can start helping mental health without having to really jump first to medication. Maybe there's some digital therapeutics we can create because what we've created at Neurosity is essentially a speedometer for your brain. And we can tell when you're over speeding or when you're under speeding, and we can sort of help you get up to speed and maintain that speed. So that's really what we've done at Neurosity is create that, but the corollary is to focus. And I've been working on this right now for about, at Neurosity for 5 years, and in total, about 8 years of my life has been dedicated to creating this new interface and computing platform.
So AJ, where did you first get the idea of Neurosity? How did it start?
Yeah, I think the really like all spark of it was my father. He grew up teaching me computers. Some of my earliest memories are sitting on his lap, him teaching me about Linux. And I just remember looking up at him and him saying like, "Why does the computer not know that I want to save when I'm done typing?" And that really created this seed of an idea as to why are computers not learning from humans in the same way that humans learn from computers. And that really led me down this path of discovering computer engineering at university, discovering embedded computing in my internships, going to Boeing and learning about these massive aeronautical airplanes that are being built, these $300 million products, and about how there's robots that are being used to build these now, and the future is robots working with humans, and we're only going to need a higher and higher bandwidth, interface between the human, the factory worker, and these collaborative robots that are continually coming up online in factories all over the world. And it was that realization, understanding that if we just had one mental tap that we could communicate with to the robot, that could prevent, two pieces of material colliding on the manufacturing floor at Boeing, saving, hundreds of millions of dollars of damage because someone could get the robot arm to stop faster than they could yell stop or run over and hit a stop button, right? This is like an error potential that the brain immediately does, and we're in milliseconds here. So very, very fast ability to really stop the system. And that's really what made me, leave Boeing in 2015 and continue working on that. But why I'm here today and why I'm still here and why I'll be here for the next 25, 30 years is because I really want to create that system where computers are able to learn from humans faster than humans are able to learn from other humans. You and I are exchanging a ton of meaning right now, between each other, right? But imagine the world where I could exchange even more information about myself or my desires with a computer almost instantaneously at the speed of thought, faster than the compression of I have to, create words, but really this incredible high bandwidth interface. And that's what I want to create a machine at Neurosity to invent. And that's what we've been working on, and it's super exciting.
So AJ, can you tell us actually how BCIs work under the hood?
Yeah, so there's a couple different, concepts here, but essentially the brain is an electrical, chemical system that emits information that you can pick up in the form of many different, ways. You can do an fMRI that's looking at the magnetic changes in oxygenation of blood, right? Because as neurons fire, they need oxygen, and that causes a change in blood flow, which can be seen on an MRI, especially an fMRI. And so you're really looking at, this concept of the brain is always doing this thing, but we're creating the technology to listen to it for the first time. I kind of equate it to like where the Wright brothers created the first airplane, right? It's not like the airplane couldn't have been invented 100 years prior. Air still existed, right? But we got to this point where we had an understanding of the technology enough. And I think that's really where we're at with, BCI. And BCI, brain-computer interface, the first couple of years where I was in this field, I was really focused on BCI as this idea of, an instantaneous translation machine between the activity going on inside the brain and a computer. And it's this like instantaneous communicator as if you were talking through a translator. Where, instead of, if I want to talk to my friend who's French, but I don't speak French, I can speak to my friend in English, who then translates to French, and it's the same thing. That translator is the BCI. And what we really discovered at Neurosity early on was that you need to put, really the entire computer or most of the compute onto the actual device to create an incredible, stable, autonomous device, because BCIs in a lab are essentially, these big nets hooked up to your head or machines that are hardwired to a computer, so there's no data loss, and they're inside a shielded room. And they're doing incredible work with BCIs all over the world in these very specific circumstances. But what we did at Neurosity was really package that entire system, the thing that scans your brain and images it in that instantaneous translator, the computer that's hardwired up to it, and all of that fits inside of this, small little package that can go right on the back of your head like that, and is able to essentially do the pattern recognition locally on the device, is able to do a majority of the compute on the edge, and it becomes really this stable, nice system that can be used for building applications with. So a lot of the BCIs you'll see out in the world are really that instantaneous translator. When you hook up a computer to the BCI, you now have the ability to do pattern recognition and machine learning. It's essentially that untethered Oculus, right? How they went from tethered to untethered because they put enough compute on it. It's really that same concept, and that's what Neurosity did with BCI.
So AJ, can you tell us more about Neurosity's Crown, your main device, and the gadget you just showed us?
Sure, yeah. So Neurosity's Crown is the third generation device that Neurosity has put out. It's an incredibly powerful, almost clinical grade EEG system that any consumer can have at their house within a couple of weeks just for $99 a month. We'll ship you the device and you can use it for as long as you want. And the application that you'll be using with it is this concept that we've pioneered, where you listen to music for 5 minutes before you start working. And there's a lot of secret sauce in here, but the secret is that we can essentially scan your brain and predict what sounds, what stimulation, what music do we need to play in order to elicit the desired electrical response from the brain. We treat the brain sort of like a state machine where, as a game developer, you can kind of move through states. And a really fun way that we've learned is like, hey, we help people go from this state of unfocused to focus. But what we're discovering is that you have to be in almost a meditative state in order to shift into that focus state. And if you can't be in a meditative state, then you're probably not going to be able to shift into that focus state, that flow state, where you feel like time sort of slows down. It's the feeling we have when we're working on something that's incredibly interesting. And we can essentially get your brain to match that brain activity, even if it's not something that's interesting. Because you close your eyes, you listen to music for 5 minutes. We've created our own custom music, and we essentially have this reinforcement learning algorithm that's taking your brain data as input and is predicting what's going to drive your focus up. And if the activity in your brain actually increases, we'll reward the system. And if it decreases, we will punish the system. And we continually get better every single time you use it. It gets more and more accurate and gets better and better at predicting exactly what music you need to hear at this instantaneous moment in order to shift you into a flow state. Because if you're just using sounds, it's only about 80% effective. But you need to have that closed loop feedback where you're predicting and you're essentially telling, if I give the brain a stimulus, how does it react? If I give the brain a stimulus, how does it react? And you're getting better and better and better at that. It's almost like we're a parent learning how to soothe their baby for the first time. We figure it out and then we get good at it. And maybe you need to hear Twinkle, Twinkle, Little Star today, but tomorrow it's, Itsy Bitsy Spider, right? So really being able to create that automatic predictive system that, humans can rely on in order to move in the state machine.
Awesome, great. So AJ, can tell us more about your design philosophy? Because usually BCIs are these weird devices that you put on your head, and they aren't actually something that you want to put on your head because they are not very good looking. But your devices and Neurosity's Crown is, I think, the most fashionable device in this market, and it is actually something that you want to put on. Can you tell us how did you reach this design and about your design philosophy?
I have a fantastic co-founder, Alex Castillo, who has a degree in design from Parsons University in New York. And when he and I really started, what I had was this fundamental underlying hardware technology that had, like a Raspberry Pi with my own custom PCB. And I had it in essentially headphones that looked like this and a huge 3D printed box on top of my head. And Alex and I joined forces in 2018, and we both looked at each other and we were like, I know, we can't ship this ever, but we need to make something. And Alex wasn't, he was really a software engineer fresh from Netflix. So he really went coding with his design degree versus, physical design. But we had no choice. He had to come up with a design. We essentially said, there is, I remember telling him, I was like, there is no one else to come up with the design. It's just you and me. We're just co-founders. We don't have any money to pay anybody. You need to come up with it. And he was at a dinner with his girlfriend's parents, and it was like a steak type dinner or like a steakhouse. And on the wall was heads, adorned, trophy heads of animals that were hunted. And he saw the ram's horns and looked at how that sort of braced the head, and that's really where we were inspired for. It was the ram's horns. We knew that we wanted to create a whole head scanning device, something that was imaging the motor cortex, which really runs from ear to ear. So that's really what led the design that, hey, we want sensors going through the hair on top of the head. And that's really why you end up seeing a lot of not so attractive BCI devices, is because to be able to fit all head shapes and hairstyles and go through the hair, it's really hard to, make sure that it looks really good, because, the best system has essentially each electrode can articulate itself, and then it ends up looking like spiders, and it's just this really not attractive looking device. I think what we also wanted to do was keep the face clear of the device. I didn't want a headband. I think the face is the most beautiful part of any human. And to block that or obstruct that, and to not really add to it, is a big no-no in my design philosophy, right? We want to have something that people feel excited to wear, and that they feel empowered, that they're being crowned when they wear it. And as we continue to evolve the devices, we'll continue to use that principle of, hey, this is something that, it's way easier for us to scale when people say, can I try it? Instead of us saying, will you let me put this on your head, right? So it's a way different conversation. And I often will say this is a 51% branding, 49% tech company. And we really started in Soho in New York, looking at street fashion, that streetwear. I loved the idea of Tiffany and how they present their boxes. So a lot of what we look at, and we play really hard into that crown idea. Any metal that you see on the crown is gold plated. You could really see there's a lot of attention to detail. And I think one of the biggest things that as this was our third generation device, I learned that it's okay for me to be extremely detail oriented when I'm designing a device here. And if I want something a specific way and it's not getting to that point, I can, push it and get it to that point. Any time that I see something that I'm like, oh, that might break in production later, and my intuition starts saying like, oh, that might not be a good idea, I learned to really listen to that. And that took a while to really trust that like I do have good intuition. I have listened to my customers. I do know what we want. I do know what will break. And really learning that. And at this point, now I know that it's okay as the lead hardware engineer to be extremely detail oriented with a hardware product, right? That, everything from how someone takes something out of a box to, the pamphlet and everything about it, needs to be as good as we possibly can get it. And I think that's really has been the guiding design philosophies at Neurosity.
Great. So, AJ, can you tell us how do you see the role of the AI in BCIs, and especially the current trend of AI, which is generative AI? Do you use AI in your processes and in your softwares?
Yeah, I mean, the brain is AI, right? The brain is AI, right? So in order for us to learn the brain, it's going to be an extremely easy analogy for us to use AI to essentially reverse engineer the electrical activity that's coming out of the head. So that's really why we use our current use of AI is that subset called reinforcement learning that's continuously learning more and more about you every single time you use the device. The generative part is coming from really three directions that I'm seeing right now. First is, we have, 10,000 data sets that people have opted in to upload for our research program. I think it's like 10, some number, maybe 1,000, I don't remember. But we can then turn that number, say we have 1,000 data sets, into 100,000 data sets using generative AI, where we essentially are taking and training a neural net to predict the next EEG sample. Given, the last minute of EEG data, it should be able to predict the next EEG sample in a way that we can generate, a ton of data sets to then go back and influence the generalized model that we're creating. Then the third one is really like in music. So being able to generate music in real time, such that like the song, like right now we're using a catalog from neuromusicians, but we definitely see in the future you'd be able to use generative music to essentially compose in real time what we're predicting is the perfect music and genre and instruments that you need to hear in order to make your brain move from one state to another as fast as possible. And then the third generative one that I'm seeing a lot, I don't think it's generative, but I was just doing this last night and it was blowing my mind. But the advanced data analytics component from OpenAI as part of ChatGPT 4. I just uploaded it like 16 of my data sets, of my EEG data sets, and it was doing, data analysis that was way more hardcore than I could using state-of-the-art Python toolboxes. And I even got it to a point where it could write me an email and pull out a key insight from my latest data set, comparing it to my previous 15 data sets, right? And being able to automate the analysis of EEG data at scale, it's just fascinating, right? Like the fact that, and I showed it to my neuroscientist, and she was like, "I didn't know you could do that. Like, what? What?" Like, it was wild. I mean, but just step by step, this little Chat GPT was just attacking it. So, I mean, I can really see us getting to a point where we are, using the the OpenAI API to essentially, obviously, if you opt into it, but be able to create this fleet of neuroscientists that are just continuously trying to look at your data and give you insights. And that's something that we can charge people money for monthly. And I think that's super exciting for us. And those are the three ways that I think AI is really playing well into BCI.
Great. AJ, can you tell us what are the most important and most useful use cases and applications in the BCIs right
So
now?
there's two different types of BCIs that I really consider. There's invasive and non-invasive. Um, Invasive is really good for like control or just like direct bypass or stimulation, right? Where let's say you have a spinal cord injury, you can essentially take the signals from the top of the spinal cord, wire it around the spinal cord, and stimulate below the injury and restore the ability to walk. BCI, super cool. It's amazing. That's the Neuralink stuff. There's a company called Science that's working on like an eye prosthetic. So that's BCI. Instantaneous communication machine, right? That is doing this instantaneous thing. And then the next level is that non-invasive, which is really more, it seems to be much more at like major mental states or attention adherence, right? Where you're like looking at how meditative the person is, how focused the person is. You can sort of see signs of depression, anxiety, PTSD. There's really a lot of Alzheimer's. You can tell Alzheimer's progression. A lot of that type of information you can gather from outside the head. And you don't have to be on the inside just to figure that type of stuff out. So that's really, the next set of use cases. I think being able to create, a preventative mechanism, that can help people with rumination, if they're, stuck on a ruminating thought and can't get out of that mental state, to be able to help push them into another mental state that they want to go into. I think that's going to be an incredible use case. Imagine even being able to get like it paid for by your insurance or your HSA. I think another one will be, being able to measure cognitive and prevent cognitive degradation over time is another big one. Neurosity itself is attacking focus as a main one. Focus, we're very focused on focus. We're about to launch a meditation shift because we found that you can't, if you're not in a meditative state, you can't shift into focus. So now we're launching this like guided meditation that's in beta right now internally, and it's just absolutely the most incredible piece of software that I've used and that we've built. Really being able to create a product that helps people who aren't good at meditating be good at meditating, right? I think a lot of people, myself included, will hear like, oh, you should try meditation. It's really good for you, from really experienced meditators. And what you end up finding is that like doing meditation is work, and it takes work to be able to do meditation. But I need a guide, I need help. And what we've been able to do is create and use that same reinforcement learning to be able to create a guide that's adaptive to you. The words are adaptive to you. The music's adaptive to you. Everything is part of this reinforcement learning. And we have multiple agents now trying to work in parallel and really pushing this concept of, use the state-of-the-art research, put that into application, and do it in real time and really, push on it. And so you could really see a lot of like potential use cases of BCIs in the research, right? If you go look at the last, 1,000 papers published, using EEG, and you did a word map on that, you would be able to then go extrapolate, where are the next best use cases based on, what has the most, hits on it. And essentially, where is the largest unmet need in the population, right? There's no clear alternative for focus. We have stimulants and we have, SSRIs for these, different medications, but the brain is the one organ that we're diagnosing and prescribing without even measuring, right? We have doctors that are prescribing medication, but they're not even measuring it. So, anytime you can bring that measurement, right? If it's a concussion and ready to play, I hear that a lot of like, athletes have to do like a weekly cognitive test. And so being able to bring this as part of that weekly cognitive test, such that if they get an injury, they can compare their cognitive test reports and see if they're below their baseline, right? So, there's so many different ways you can leverage this technology. It's incredibly exciting. I think that's why, part of what we're doing here is building a platform for third-party developers to be able to build applications on and really create tremendous value for our users that they didn't have yesterday that they're now very excited about and using. So there's a million use cases. I often call it like the lighthouse effect, where you're standing at the top of a lighthouse and there's 360 different ideas you can have and you don't know which one to pursue. But really try to find that like unmet need, something that people will pay for today, is really, there's a couple of those for sure.
Great. AJ, can you tell us how do you see the role of BCIs in the future of the metaverse, and how these devices can augment and add value to technologies like AR and VR?
Education seems to be one of the biggest use cases for VR, right? And AR and XR, it seems to be like the most money is in that, is the most money is in this education sort of segment. So I'd like to see something involved with that, whether, you're creating more adaptive, materials for the students who are learning in real time based off of their like cognitive processing, right? So that you're creating this incredibly adaptive and you're predicting what imagine a world where when you're creating educational materials, you're predicting what the user is going to be able to get right based off their brain activity and based off their, understanding, and you're essentially creating something that the person feels really good at and is learning along the way instead of getting frustrated. And being able to create that really tight predictive loop, I think that's going to be incredibly helpful for a lot of people. So that's my favorite way. I'd like to see it come into the metaverse.
Awesome. AJ, can you tell us how do you see the future of BCIs? Do you see a future more like Matrix, where you plug in the BCI in the back of your head and completely immerse into the Matrix?
Definitely. I definitely do. I think my favorite analogy, like thought experiment here, is like, okay, if you did live in the Matrix and information was instantaneously available that changed the signals from your brain to your ligaments, that essentially, you said you wanted to punch and it like punched perfectly, right? Or like you wanted to ride a bike and all of a sudden you're riding a bike and your body just knows how to do it, right? I think, why do we humans learn, right? It's such an interesting question. And we learn so that we can then like do the thing, right? We learn to farm so that we can grow food, right? We learn to bike so that we can travel. And I think it will be very interesting when, you look at a kid who wants to like learn how to bike or something so that they can go mountain biking with their parent, right? Well, it's going to take years before that kid is able to go keep up with their parent who's been mountain biking for 20 years, right? But in this world where the kid is as good as the parent, this instantaneous second they start trying to do it, I think that just creates a whole new world of adventures for people. And a lot of the time will be spent using the knowledge versus trying to gain the knowledge. You'll see sort of this shift in humanity where we're not putting all the emphasis on learning, we're putting all the emphasis on doing. And I think that's what's really exciting, right? You don't need to practice, for 5 years before you go to Spain, right? You could just go to Spain and speak fluently, right? Like, you don't have to do all of it's the hard stuff, right? So I think life will become incredibly fulfilling, more and more fulfilling as we continue to abstract the hard things away. I mean, imagine life is much easier now that we can put clothes in a washing machine instead of having to like wash them with our hands, right? It's the same concept where it'll be much easier to do a lot of these things because we don't have to, we've abstracted away the challenging part of it, and we can use our minds for something that's much more enjoyable, like feeling great following your dad going down a mountain biking path and having a blast, right? Versus the struggle of dealing with a broken arm because you fell and you had a bad time, right? And you never do it again. Two totally separate things, right? And I imagine this world where if you did get a panic attack, you'd be able to quickly like self-regulate back, right? And to prevent that from happening, and just this instantaneous predictive world, I think is just absolutely beautiful and fascinating.
Awesome, great. So AJ, as we all know, one of the most famous and most important BCI companies is Neuralink, which is one of Elon Musk's companies. How do you compare Neurosity with Neuralink?
Well, I think Neuralink's an incredible company that has, put together an incredible team that is working on one of the hardest problems right now, which is control and that invasive control. So, I think as long as Neuralink continues to do a great job testing and being open and working with the FDA and staying on the path that they're doing, I think they'll get FDA approval before like Neurosity does. I think Neurosity will get FDA approval for some of our devices, in a couple years, probably like 2026 timeline, because we can ship our device before we get FDA approval. Because we can create like just a remote patient monitoring device that's extremely low risk to the human, we have the ability to really sell tens of millions of these devices before we try to make a claim that like, hey, you get your insurance to reimburse you if you have general anxiety disorder. You can get reimbursed for this, device monthly. It may take us a couple of years to get to that point, but what we can do in the meantime is sell tens of millions of devices to people who are looking to have that, high ROI when they have that feeling of, I want to focus, but I don't feel like I'm going to be able to focus, and I don't know why, and I need a little bit of help to just get me into that space, into that mind state, and I think that's really where, it's going to be way easier for us to sell 1 billion devices than like Neuralink that has to drill a hole into someone's head. So I think the ability for us to affect change, attack the market, make the capital, return our investors' capital in a much, in a very exciting way, I think is much more approachable and possible when you have a non-invasive, device that is at the cutting edge of science and is imaging in a way that's never been before possible. So yeah, I think that's the difference.
Awesome. AJ, you have one of the most interesting business models I've seen in this field. And you actually have a subscription for a hardware company, which is not something you see every day. Can you tell us more about your subscription plans and how you price your gadgets and how your subscription models work?
So the way that we've been really successful is continuously exchanging value between ourselves and the users via a membership. Something that our users join because they want to be able to have an answer to that. I feel like I want to focus, but I don't know if I'll be able to. So that to me is worth about a coffee a day to have that, ability to get better at that and to have that ability to do that consistently. So that's really the product that we've been trying to sell the most and get the most traction on. We have a lot of users who will, buy the product for that and will then use it for, tracking, focus tracking, different use cases. We have like a way that you can use, Spotify with your device, and that's all sort of included in this $99 a month price. And if the device breaks, I have like a ask questions later policy where let's just get you a new device as fast as possible, because all that really matters is that when you have that feeling that you want to focus, you have a device that's ready right next to you, plugged in, ready to go. And I think that like those principles are really where we want to continue to push. And the next devices that we'll be pushing out of Neurosity, and we've actually been like starting to look at equity crowdfunding and starting to work at how are we actually going to get this device to market, is create a much smaller device that's really like the size of a nickel that goes right on your temple and is much more intuitive to use. And it follows these like 5 guiding principles that we've discovered using the Crown and being first to market here, but The 5 are: it must fit all head shapes, it must work on all hairstyles, it must work across all skin colors, it must be as intuitive to put on as a wedding ring, and it must be hyper-focused on psychological shifts as a service. And, the Crown can do a bunch of things, right? So it's a general purpose brain computer. I don't think that's going to go anywhere. I think researchers need general purpose brain computers. I think to develop new algorithms, we need general purpose brain computers. I want to add more sensors to the Crown. I want to add it so it's like 50 sensors or something on the Crown, on Crown 2 or Crown 3 or something, right? Where we're improving this ability to scan the entire head. But then I'm going to open up an entire another market, which is just for the psychological shifts as a service. And we're really hyper-focused on that concept where, we can really follow much more of an aura model, the ring model where, you're paying $299 up front. We'll ship you this little next-gen device. If anything breaks or anything like that, we'll ship you another one. But you'll essentially then be paying, $6 to $20 a month in services for those insights and that ability to continually shift into focus. And we really need to switch our business model in order to scale the company into that, because the Crown right now costs more money than we make per month than that initial setup fee, right? So the Crown takes like 5 to 6 months to get paid back for at least. And so that initial month doesn't cover the entire cost. But when we switch the business model to something that, we get paid back for immediately on purchase, and then we're making monthly services on top of that, it's a much more exponentially scalable business. And so we really had to push the company to get into a point where we can be exponentially scalable without having to continuously raise capital, but just from our own ability to sell the product. We have this continuous value exchange where we're bringing in more money than the device is costing us per month to produce, and then we'll be able to really scale it. So the business model for the Crown has been incredibly effective for getting a ton of people through the door, trying it. We have a lot of users who will only use it for a week, but we have a lot more users who will use it. We have a really significant number of users who will continue to use it for over 3 months. And we'll use it 60% of their days are Monday, Tuesday, Wednesday, Thursday, Friday that they continue to use it. So we really want to be able to open up a lower cost, much more scalable business model device that's just focused on that shift user, something that I could send my mom, she could put on her head. It doesn't have to explain, they don't put it on backwards, they don't put it on sideways, they just put it on their temple because everyone can touch their temple, right? It's something that every human knows how to do. So that's really, what I'm excited about. And that's the business model that, I'm pitching a lot and I'm very excited about myself in creating.
Awesome. AJ, can you tell us how our listeners can find you and your company, Neurosity, and how they can actually have an experience with Neurosity's Crown?
Yeah, so we've done an incredible job of making it as easy as possible to get a Crown. You can just go to neurosity.co. That's neurosity.co. And you could also Google search Neurosity. But you can then get our Crown for $99 a month. Try it out. You'll really love it. We got this new meditation thing coming out. It's very exciting. You can find us there. If you want to look into really the behind the scenes of the business model and where we're going and the finances and all that type of stuff that you don't normally get to see in a startup, well, I have good news for you. We just launched an equity crowdfunding campaign on WeFunder. So if you go to wefunder.com/Neurosity, you'll be able to see a really fun video from the team outlining our vision and where we're going and what we're doing. And you'll be able to see that we've made, over $2 million in revenue since we started this company, over $1 million in revenue over the past 12 months. You can really see all of that information. It's super fun. You can learn about the team and everyone else. That's wefunder.com/Neurosity.
Awesome. We will surely put links on the description of the podcast. AJ, it was great having you on the All Things XR podcast. Thanks very much.
Likewise. Thank you so much for having me, and I look forward to continuing to get to know you.